While executives allocate millions to govern cloud-based artificial intelligence, the reality of how their facilities actually operate looks very different. Down here, Tier 2 manufacturing is often held together by a decade-old laptop, quietly running an undocumented Excel macro under an engineer's desk. This is shadow automation. It is the ecosystem of unsanctioned Python scripts, low-code tools, and desktop macros that operate completely outside formal IT governance. Because these tools live outside approved channels, they carry immense operational risk. There is no version control, no backup protocol, and no formal validation to ensure the data they process is accurate. This creates a bottleneck known as the hero engineer. When the single person who wrote that fragile script takes a vacation or leaves the company, the business continuity of the entire facility goes with them. The most immediate threat to industrial operations isn't an external hacker. It is the internal, invisible digital infrastructure that nobody officially owns. This diagram illustrates the core hardware constraint. On one side, we have legacy PLCs, the analog-era controllers running 70% of manufacturing. On the other side, modern cloud databases. But a massive gap exists between them, because those legacy controllers lack the native APIs required to communicate directly with enterprise software. This gap creates intense friction. Information technology demands strict security compliance, while operational technology is judged entirely on keeping production running. So, to bridge the divide, operations teams build their own workarounds. As data pulses across this fragile, makeshift connection, the physical machines keep turning. The floor engineers building these bridges aren't acting maliciously. They are solving a structural failure to keep the assembly line moving. Now, artificial intelligence is accelerating the problem. Generative AI allows anyone on the floor, even non-programmers, to instantly write a complex integration script with a simple prompt. A quick AI prompt might temporarily patch the API gap, but it multiplies corporate liability by injecting unvetted, untested code directly into a physical production environment. Eventually, an IT audit scans the network and uncovers this unsanctioned gateway hiding in plain sight. The standard operating procedure for IT is immediate and strict. Quarantine the rogue script, firewall the connection, or delete the code entirely to restore cybersecurity compliance. But the moment IT kills that fragile macro, the heavy machinery grinds to a halt. The production line it was secretly sustaining instantly collapses. This is the break-to-fix paradox. Leadership finds themselves trapped because enforcing digital compliance actively destroys the physical output of the business. The solution requires a philosophy of restorative legibility. We have to formalize undocumented code without punishing the engineers who built it out of necessity. Instead of ripping out cables, the first step is observation. This diagram shows how deploying a passive, zero-trust network overlay maps the chaotic web of data handoffs, bringing a clean architectural grid to the hidden ecosystem without requiring any operational downtime. Once visibility is established, we move to discovery. IT must ask specific diagnostic questions, like the one shown here. Where do manual overrides happen, and which critical reports rely on a single user? Phase 3 is formalizing the inventory. These rogue scripts must be treated as load-bearing infrastructure and systematically brought under formal version control. For this to work, C-suite governance has to adapt. It must move out of abstract cloud theory and align with the heavy, analog reality of the factory floor. Before drafting another high-level policy on artificial intelligence, organizations need to map and secure the hidden scripts that are actively keeping their facilities online today.